All right, welcome to the second part of this review, and let's get started. The next question that you guys did do so very well with was question number 75. And question number 75 says, identify the month and the day when the noon sun would be directly overhead at location B. So look at this diagram. It shows the continent of Australia, and it's asking for that location B when the noon sun will be directly overhead of it. So you will notice that the point B is on this broken line, and that broken line is 23.5 degrees south. What is the name of that latitude, 23.5 degrees south, if you recall? All right, let's see what you guys came up with. Now, when we discussed important lines of latitudes, we said the first one is the equator, and then below the equator you have the Tropic of Capricorn, and the Tropic of Capricorn is 23.5 degrees south. The Tropic of Cancer is 23.5 degrees north, so which is different. So what we see in the question there is 23.5 degrees south. And as we mentioned, the reason for this 23.5 degrees is because the Earth's axis is tilted 23.5 degrees. So that's why the tropic above the equator is 23.5. The tropic below it is also 23.5 because of the Earth's tilt, 23.5 degrees. So when we go back to the diagram about seasons, if you recall, whenever the northern hemisphere is tilted away from the sun, then the northern hemisphere will be experiencing winter. So because of that tilt, you see that the sun is directly pointed at that line below the equator, which is the Tropic of Capricorn, 23.5 degrees south. Conversely, on the opposite side during summer in the northern hemisphere, when the northern hemisphere is tilted towards the sun will be directly on the Tropic of Cancer, not the Tropic of Capricorn. So when the sun is directly on the Tropic of Capricorn, 23.5 degrees south, then we are experiencing winter because it's on the Tropic of Capricorn, which is in the southern hemisphere, which means the sun is focusing more on the southern hemisphere. So we don't get to see the sun as we ought to in the northern hemisphere. So as a result, we get less daylight, we get less heat from the sun, and that produces our winter. So therefore, this is a winter period. This will be the winter solstice for us in the northern hemisphere when the sun is overhead at the Tropic of Capricorn, 23.5 degrees south. So to answer that question, the solstice, the winter solstice, that will be the time where the sun will be overhead at 23.5 degrees south, and that would be December 20th or 21st or 22nd in the winter solstice. So let's go back to that question, question number 75. So that would be our best answer for it. So going back to our packet, we're going all the way down to question 75. So our answer here would be December 20th, or you can say 21st, or you can say 22nd. Any of those would work. Okay, that's it. Next question was question number 77. Question 77. Question number 77 says, where are you? 77. Location D and E are located in the same distance from the Pacific Ocean. Explain why the location D has a drier climate than location E. So we see location D here and location E here. So it's true that they are both same distance from the Pacific Ocean. So the question is, why is it that location D is dry and location E is wet? If you remember this symbol, this little inverted V represents mountain, so which means location E is in front of the mountain, and location D is also location D on the other hand is behind the mountain. And that brings us to the concept that we discussed about orographic effect. If you recall, we said whenever wind is coming from the ocean and it meets a mountain, the wind is forced to move up the mountain, and the higher you go, the cooler it becomes. So as a result, the moisture in the wind condenses because of the low temperature as the wind moves up the mountain. So the water vapor is condensed out of it, forming clouds. So one side of the mountain will have clouds, and eventually that clouds will give birth to the precipitation, the rain, on that side of the mountain. So that side of the mountain will be wet with a lot of green vegetation. However, once that wind gets to the peak of the mountain, since there's no obstruction, that wind will begin to descend. As a result of that descent, the lower you go, the hotter the wind becomes. And this wind does not have any moisture anymore. Why? Because the moisture has been taken out of it on this other side of the mountain. So as a result, this side of the mountain, called the rain shadow, will be hot and dry. So a recap here. This side of the mountain that has the moisture is called the windward side, usually the side facing the sea. While the dry side, the hot side, is called the leeward side, or the rain shadow side of the mountain. So that would explain why one side of the mountain will be dry, the other side of the mountain would be wet. So let's reattempt that question again. Why is location, question 77, why is location D drier and location E than location E? So the answer would be location E is on the windward side of the mountain, while location D is on the leeward side of the mountain. Let's put that in writing in our packet here. All right, so we'll say location D is on the leeward. Leeward is the side that is dry. It's on the leeward side of the mountain, while location what was that word? Is that location E? Yeah, location E is on the windward side of the mountain. Windward side of the mountain. All right, I think those are the words that they really want you to remember or to use while answering this question: windward and leeward side of the mountain. All right, so we're getting there. We're almost done. Next question that you guys did the worst with was question number 83 and 84, and we'll wrap it up right there. Question number 83. Question number 3 says, for an observer on Earth, identify the direction a rocket path appears to curve due to the Coriolis effect as it travels from near the equator towards the North Pole. So we have a rocket traveling from the equator and traveling up to the North Pole. That would have been a straight movement, of course, but as we know, within a circular system, we have the Coriolis effect. So this Coriolis effect is on our Earth Science reference table, page 5, when we talked about ocean current, and also on page number 14, I believe. Page number 14. So let's look at page number 4 first. So if you look at page number 4 right here, and we divide this into north and south hemisphere, you see that all the ocean current in the northern hemisphere, they are going in a clockwise manner, right? They are moving in a clockwise manner, the direction the clock would tick to in the northern hemisphere. While in the southern hemisphere, it is counterclockwise, which means the opposite direction. All right, important distinction to note there. So the question was asking us, in the northern hemisphere, as the rocket moves up towards the North Pole, in what direction would it curve to? By default, it's going to curve clockwise direction because of the Coriolis effect. All right, just to buttress that point, look at this diagram more carefully. You see that all the arrows are going in a clockwise manner and going in a clockwise manner, or curving towards the right. All right, in the northern hemisphere. Important distinction: in the northern hemisphere. It is opposite in the southern hemisphere. In the southern hemisphere, they are going counterclockwise. So our answer to that question for question number 83 would be right or clockwise direction. All right, curve to the right, let's put it in full sentence. Curve to the right. All right, I'm losing my spelling of right. Or you simply say clockwise direction. Clockwise direction. Simple. That's it. And then question number 84 is just a follow-up question. Describe the relationship between latitude and the amount that the wind deflects due to Coriolis effect. So as you know, the equator, the value of the equator is 0. And then the value for the North Pole is 90 degrees north because it's the northern hemisphere. So the further you move away from the equator, the higher you go with your latitude, the higher you go with your latitude. So which means the further you move away, the more deflected the rocket will become. So as latitude increases, the deflection from it would also increase in that clockwise direction in the northern hemisphere. So as one increase, the other is equally increasing. That is what the question was asking. Describe the relationship between latitude and the amount that the wind will be deflected, that is curved, due to the Coriolis effect. And we know the Coriolis effect would deflect things to the right or clockwise direction in the northern hemisphere. So let's type that down, and then that'll be a good wrap for us. The higher the latitude, the higher the deflection, or you can say the Coriolis effect. The higher the latitude, the higher the deflection, or Coriolis. All right, Coriolis effect. That's it. Easy peasy. There you go. All right, and that's a wrap. So next couple of slides that you're going to see on the Nearpad would be similar questions to these questions that we have looked at. Then I want you to reattempt those questions again using the explanations that we've presented in this video so far. All right, till next week. Bye.